we're going to look at some tricks here, some problems that are different. So they're just a little bit of a different setup. They may involve partial fractions or not at all. So just because they're rationals doesn't mean we're going to be using partial fractions. So that's what this video will look at. So our first one here is we have a denominator of t squared minus 1. And we may initially just think, oh, this is a quadratic. However, t squared minus 1 is factorable. So if you had t squared minus 1, this would be t minus 1, t plus 1. And so if we put a square around it, that means each of these is also squared. So what we really have, I'm going to put the 1 on top, is t minus 1 squared, t plus 1 squared, dt. So if we write this as a partial fraction, then we would have a over t minus 1 plus b over t minus 1 squared plus c over t plus 1 plus d over t plus 1 squared. And then we would just continue on to find our partial fractions. But again, we're just setting this up. You know how to find partial fractions using this. So you can find the a, b, and c, plug it back in your integral, and integrate. All right, let's look at another one. So this one is long division because, well, 5 is bigger than or equal to 3. So our top degree is bigger than our bottom. So we need to divide. So x to the 5th, and then we don't have an x to the 4th. We don't have an x cubed. We don't have an x to the squared. We do have an x and a 1. And then we're dividing that whole thing by x cubed plus 1. And you could put in the 0x squared and 0x in here, but we're just going to leave it this way. All right, so degree 3 means we count in 4. 1, 2, 3, 4. So we're multiplying by x squared. And so x squared times x cubed is x to the 5th. So that checks perfectly. And then we continue. So the next one would be times 1. So that would be x squared. It goes here. And then we change signs. Make sure we... All right, and those cancel. And so we would get nothing, negative x squared plus x minus 1. All right, so now we have x squared minus, and then it's negative x squared plus x minus 1 over x cubed plus 1. And then your first thought, well, what do we do now? That's a cube. Well, this is factorable, x cubed plus 1. So if we take and do x squared, this would be minus, right here, there's a negative. So I'm going to take and distribute, that's a plus actually, plus, and then we get negative x squared plus x minus 1. Now, x cubed plus 1, it would be x plus 1. And if you remember the signs, it's same, opposite, always positive. And then the first would be x times x, so x squared. And then x times 1, so x. And then 1 times 1, so 1. And you notice, look at the top. That's right, it was factorable. So these are opposites. They have a negative 1 opposite of each other. So you see it's negative plus negative, positive, negative, positive. They're the same thing. So we can cancel them and put negative 1 up there. So what we end up with is just x squared. I'm going to put a minus, might as well, 1 over x plus 1. Now, you have something that you can integrate. And since this is simple, it's 1/3 x cubed minus the natural log of x plus 1 plus c. So let's just take the integral. All right, so there's another option. So notice we didn't have to use partial fractions at all. So you always want to make sure that if you can factor this at the end, you factor it and see what you get. Now the last one, your first thought is like, look, we have an x to the 5th. I can factor out an x and continue from them, but just look straight above. You have a 5, it's a 4. A 3 is a 2. A 1 is nothing. That's possibly a u substitution. So that's where you want to go right off the bat. So if we take our x to the 5th plus 5x cubed plus 5x, we're throwing this at the wall to see if it sticks. And they have a 5 in common, right? There's a dx there. So you can see if I factor out that 5, I get x to the 4th plus 3x squared plus 1. It's the numerator. Look at that. So that is that. And so that is our dx. So if I rewrite this, this is du over 5 is that x to the 4th plus 3x squared plus 1. dx. So we can just do a quick u substitution. So this would be 1/5 du. So now we got rid of the top, the x to the fourth, and our dx. And then now we just replace that with a u. And we're ready to go. So 1/5 natural log of u plus c. And then we plug it back in. ln x to the fifth plus 5x cubed plus 5x plus c. And so these are just different situations where you could actually be using partial fractions, but it's not set up correctly. So initially you still have to factor. They don't always, just because it looks like it's factored doesn't mean it's fully factored. Or it could look like a partial fraction after you're done, but if you factor the denominator, it just cancels and you're done. You didn't have to do partial fractions. And on this one, it was just you plain u substitution. So you don't know what they're giving you as a rational expression. So it is possible that if your partial fractions are not working or you're hitting a wall, that it requires one of these three techniques.